Hello students, welcome to Shri Classes. We'll start lecture number 4, and in today's discussion we are going to understand about the functional groups, general formulae of representation of these functional groups, nomenclature of functional groups. A simple nomenclature we'll try to understand. When these functional groups are attached to hydrocarbon chain, then how to read and how to name depends upon a particular rule, a nomenclature, part of which we have studied in our last lecture, that is for alkanes, alkenes and alkynes. Now, when these functional groups are attached to those hydrocarbon chains, how to name? Let us study those things under nomenclature of functional groups. So, let us start with what are functional groups. I think camera is already adjusted to the TV here. So let us start there. Okay, hope you are able to see clearly the things. So in order to understand functional groups, let us understand what is heteroatom. Heteroatom or group of heteroatoms. What are these things? Let us try to understand. See, in a carbon chain, carbon can link with hydrogen is what we have seen already. But carbon can also form bond with other than hydrogen, such as halogens, oxygen, nitrogen and sulfur. Other than hydrogen, to which the carbon can bond, those atoms are called heteroatoms. Halogens are nothing but fluorine, chlorine, bromine, iodine. Then oxygen, nitrogen, sulfur. So carbon can form a bond with all these atoms or probably with a group of these atoms also. So these atoms, halogens, chlorine, bromine, fluorine, iodine, oxygen, nitrogen and sulfur, these are called heteroatoms. And if such groups are attached, or if the carbon bonds with a group of these atoms, then we say group of heteroatoms. So in simple terms, other than the hydrogen, the atoms to which carbon can form a bond, those atoms are called heteroatoms. I hope this definition is very clear. So you can note down from this paragraph also. What about functional groups? Read the definition here, which is very important. Heteroatoms, these atoms, or the group of heteroatoms, that is the group of these atoms that confer specific properties to the compound regardless of the length and nature of the carbon chain are called functional groups. So definitely we understood functional groups are heteroatoms or a group of heteroatoms, that is a group of these atoms. When those are attached to a carbon chain, irrespective of the nature and length of the carbon chain, then these heteroatoms or the group of heteroatoms will confer, meaning will give specific properties to all those compounds, and therefore those are called the functional groups. That means आपको मालूम होना चाहिए, you must remember that the functional groups are the ones which are going to dictate the properties of the hydrocarbons. For example, if we attach a hydroxyl group for methane, it is methanol. For ethane, it is ethanol. For propane, it is propanol. All the properties of methanol, ethanol, propanol, all these are same. That means when we attach the functional groups, that is these heteroatoms or the group of heteroatoms to the carbon chain, whether the carbon chain length is a specific length or whatever may be the nature of the carbon chain, then these heteroatoms or the group of heteroatoms called functional groups, they give specific properties to the compound, and hence these are called functional groups. How do you attach these functional groups? These functional groups are attached to the carbon chain by replacing one or more hydrogen atoms. So let us see what are the different functional groups and then the nomenclature, how those are attached to the carbon chains and how to read them. here you can see the functional groups. These are the heteroatoms, chlorine, bromine and oxygen, and these are the functional groups and the formula of the functional group. See, chlorine and bromine can bond with carbon. Chlorine, bromine, fluorine and iodine, when those are attached to the carbon chain or the carbon atom, then the functional group is termed as halogens. So halogens are represented by X. X is equal to chlorine, bromine, fluorine or iodine, and these become the substituents for hydrogen. That means we can attach these atoms to carbon chain by removing one or more hydrogen atoms. Thus carbon will bond with these atoms. So if the heteroatom is chlorine and bromine, these will substitute the hydrogen atom and get attached to the carbon, and the functional group termed for chlorine, bromine, fluorine and iodine are called halogen functional group. How do you represent it? The formula for the functional group is represented by bond chlorine, bond bromine. This bond over here is nothing but the alkyl group. This bond will be attached to an alkyl group. This is R here, alkyl group. What is alkyl group? In an alkane, if one hydrogen atom is removed, then that group becomes an alkyl group. For example, methane, CH4, if one hydrogen atom is removed, it becomes methyl. So methyl and X can be chlorine here, chloromethane. Ethyl group, if attached to chlorine, then chloroethane. Propyl, if it is attached to chlorine atom, then chloropropane. This is how read the compounds. Okay, so reading we'll study later also. First, if chlorine and bromine, or if the halogens are the heteroatoms, then the functional group is called halogens, represented by X, and this is the functional group formula, and this is the general formula. Rx is the general formula for the carbon chain containing halogen group. Next functional group, if heteroatom is an oxygen, see here, there are alcohols, functional groups are alcohols, aldehydes, ketones and carboxylic acids. How carbon is attached to, what is that alcohol? When do you say that the compound becomes an alcohol? That is, if the carbon is attached to this OH group, means here it can be R, OH. R is nothing but methyl, ethyl, propyl, etc. So R is an alkyl group. So OH is called an hydroxyl group, or alcohol is represented by bond OH. Functional group alcohol. Representation formula of the functional group is bond OH, and bond OH is attached to the carbon atom in a chain by removing one hydrogen atom. So in that case, the general formula becomes ROH. R becomes an alkyl group here. And this OH is also called hydroxyl group. This is an hydroxyl group. Hydroxide ion is different, but hydroxyl group is different. So if you find OH in your carbon chain, it is likely to be an alcohol group also. For example, CH3OH, CH3CH2OH, something like that. Next comes functional group aldehyde. Heteroatom is oxygen. But how the oxygen is attached to carbon atom? This is attached in this form. Carbon, double bond oxygen, single bond hydrogen. This is nothing but CHO. This CHO is called, the CHO is a functional group called aldehyde. The way we called OH as an alcohol group, the combination of bond CHO is called aldehyde group, and this can get attached to the carbon chain, that is alkyl group, represented by R. So the general formula of this aldehyde is given by RCHO, or the formula of only aldehyde functional group is given by bond CHO. First we read this H and then O, CHO. But remember the bonding between carbon, hydrogen and carbon and oxygen. Carbon forms here a double bond with oxygen. Please remember over here, a carbon forms a double bond over here. So if a carbon forms a double bond over here along with one more H, then this is termed as CHO aldehyde group. Next comes ketone. In this ketone, the functional group formula is C double bond O. O is a heteroatom. C double bond O. According to valency balancing, 1 2 double bond 3 4. Another 2 valencies are left over here. But both the sides we have to attach. What is that both the sides you can attach? Both the sides you can attach the alkyl group R or and R dash. R and R dash can also be same. For example, here I can attach methyl group, and here also I can attach methyl group. That is, R is nothing but alkyl group. R dash also can be same as R. If I attach CH3 over here, CH3 over here, then this completes one compound, CH3, C double bond O, CH3. So ketones are represented by bond C double bond oxygen, once again bond. This is how we represent the ketone functional group. And the general formula for the ketone group is R single bond CO single bond R dash. But remember, between carbon and oxygen there exists a double bond over here. So valency match it, and you can count also 1 2 3 4 like that. So this is a ketone group. Then carboxylic acid group. Carboxylic acid group is COOH group. COOH group is called a carboxylic acid functional group. And general formula RCOOH. R here is an alkyl group. Maybe methyl can be attached to that one. So important here, the bonding between this oxygen and this oxygen. Bonding between carbon and oxygen is one for double bond for one oxygen, single bond for one oxygen. Of course, between oxygen and hydrogen again there is a single bond. So with respect to carbon, how this double OH group is attached? COOH is called carboxylic group. How this is represented? C double bond O, C single bond OH. This entire group is called carboxylic acid functional group. And general representation of this compound RCOOH. So for your information, listen here, OH group is called an alcohol group, CHO is called an aldehyde group, R C double bond O or bond C double bond O bond or simply bond CO bond represents ketone group, and COOH group gives you carboxylic group. So hydroxyl group, aldehyde group, hydroxyl is also called alcohol, OH represents alcohol group, CHO represents aldehyde group, CO RCOR, or you can say CO group represents ketone, and COOH group represents carboxylic acid. Apart from these halogens, alcohols, aldehydes, ketones and carboxylic acids, we also consider double bond and triple bond as the functional groups. Is it clear? We consider double bond and triple bond also along with this one. Single bond, it is not basically a functional group. Generally alkanes are without the functional groups, whereas alkenes and alkynes contain the double bond and triple bond. So double and triple bond also are considered to be the functional groups. Please keep it in mind. You can check your textbooks also, it is given there. So I hope you have understood here what are these functional groups and names. Halogens represented by chlorine, bromine or dash X you can represent. Alcohols are represented by hydroxyl group OH. Aldehydes are represented by CHO. Ketones are represented by C double bond O. Carboxylic acids are represented by COOH. After understanding this, how these are attached to the carbon chain and how to name the compound, what is the nomenclature, we'll see in the next slide. Please listen very carefully, and I hope this screen is perfectly visible to you, because every detail is most important in this slide. It is very important. Now, here the columns I'll explain. These are all the functional groups. The general formula of the functional group, and you know already the nomenclature consists of root word, prefix and suffix. between prefix and suffix you will have a root word. In this chart, what are the prefix, in which functional group the prefix is to be attached, or what are the phrases for the prefixes and for which functional group, and suffix, primary suffix and secondary suffix, for which functional groups the phrase suffix is to be added, and what is the name based on the functional group, that is we are going to see. And finally, you have one example in the form of structural formula and the name of the IUPAC name of these compounds. See, to demonstrate this entire chart, the nomenclature of the functional group, we have taken propane as an example. For all this, propane is the basic hydrocarbon that we have taken here. What is the formula of propane? C3H8, 3 to the 6 plus 2, 8, C3H8. How do you get the formula of the propane? Propane formula is based on, propane is an alkane. Root word prop, number of carbon atoms 3, general formula CnH2n plus 2, and therefore C3, 3 to the 6 plus 2, 8. C3H8 is the propane, and therefore to demonstrate in these to demonstrate with example the nomenclature of all these functional groups, the basic compound taken here is propane. Okay, and the hydrogen group, hydrogen will be replaced with the different functional groups, and let us see how we are attaching and how we are naming. Okay, fine. First case, if the functional groups are halogens represented by X, general formula is Rx. R is an alkyl group, methyl, ethyl, propyl, butyl, pentyl, like. If halogen is a functional group, we are using only prefix, meaning these terms should be used before the root word. Suffix, no suffix for this. Is that clear? That means see, suffix, of course there is a primary suffix will be there as ane, because alkanes are there. For alkanes we are attaching these prefixes, but suffix, here there is no secondary suffix. Probably I can write here as ane, but to distinguish between these functional groups and this prefix and suffix, I have eliminated that. I have not written primary, because already we know that alkane is our functional group. Everywhere there is an alkane other than these two. Here ane, all these are alkanes in the propane, and for that if we attach the halogens, what will happen is what I am showing here. So primary suffix, don't bother here, because primary suffix for the alkanes is ane only. So I am talking specifically about the halogen groups, these functional groups. So if the halogen groups is there, then we use prefix. If the chlorine is there, chloro. If bromine is attached, bromo. If iodine is attached, iodo. If fluorine is attached, fluoro. That is how the prefix phrase. Suffix, no suffix. Example here. What is the propane formula? C3H8. One hydrogen atom is taken and replaced with functional group, that is chlorine. How do you name this compound? Root word 1, 2, 3, prop. Halogens, prefix chloro, because chlorine is attached. Chlorine is attached by removing one hydrogen. So what is the functional group? Chlorine. So the name should include prefix chloro. Root word prop. All these are single bond. Primary suffix ane. Chloro, meth, eth, prop, propane. Chloro, prop, single bond between carbon atoms, ane. So this is a chloropropane. Already propane I am considering everywhere over here single bond, and propane I am considering because parent chain will have only 3 carbon atoms, and therefore propane I will retain. For propane, if I remove one hydrogen atom and attach halogen, then it becomes chloropropane. For methane, if I replace one chlorine, chloromethane. For ethane, if I replace hydrogen with chlorine, chloroethane. For propane, if I replace one hydrogen atom with chlorine, chloropropane. For butane, if I replace one hydrogen atom, chlorobutane. If I take here bromine, then bromopropane, bromomethane, bromoethane, bromopropane, bromopentane. That is how we are going to read it. So this propane is there as it is. Prop is the root word, chloro is the prefix, and ane is a single bond because these are alkanes. So chloropropane, chloropropane is the name of this compound. I hope this is very clear. Next, if I take alcohols, hydroxyl group is the representation of the alcohols. General formula is ROH, prefix no, primary suffix ane is already there because pentane we are replacing these functional groups by taking out one hydrogen atom, and therefore already alkanes I have taken. For alkanes I am attaching these functional groups. So OL is the secondary suffix. Alcohols, OH is the functional group, OH is the representation of the functional group, also called hydroxyl. General formula ROH, no prefix but secondary suffix. What is that secondary suffix? OL will be there, all. How do you attach to the phrase? That is, for root word, after the root word, the primary suffix will be ane. That E of the ane, this E should be replaced with OL. E should be replaced with OL. For example, here I have taken propane. In the propane, one hydrogen is replaced with this hydroxyl group, that is alcohol group. How to read this one? Root word 1, 2, 3, prop. All these are single bond. Propane. Functional group OH. Secondary suffix OL should be added to this, E should be removed and OL should be added. Look here, PROPANE will be there for propane, but when we add OH group, that NEE in propane, the last word, the last letter E should be replaced with OL. So PROPANE is changed to PROPANE is replaced by OL, propanol. I hope it is clear. Suppose this is CH4 methane. One hydrogen atom is taken and hydroxyl group, that is alcohol group, is attached. Methane spelling is MET, METH, meth, ane, all single bond, that is primary suffix. And if I attach hydroxyl group, OH group, then methane, METHANE, that last E is to be taken out and secondary suffix of OL is to be attached. So methanol, METHANE is changed to OL, methanol. Take ethane, attach hydroxyl group or alcohol group. ETHANE is ethane, but hydroxyl group is attached. Out of that ANE, replace E with OL, ethanol. So if hydroxyl group or alcohol is attached, then the name of the compounds will be methanol, ethanol, propanol, butanol, pentanol. Like this it continues. Third group, aldehydes. Representation, bond CHO. General formula RCHO. R is an alkyl group. And primary, what is the phrase that comes? Secondary suffix. What is that? AL. Where do you change? Last letter E out of this ANE to be replaced with AL. Example, here you can see 1, 2, 3 carbon atoms. We have earlier taken propane, but in this propane already H is there out of these 3 CHO, already C is there, in the propane C is there, already H is there, one double bond O we are introducing at the end here. So if this is written like this, then we cannot read only C double bond O as a functional group. That is not available. If that is available, ketone, but that cannot come at the end. Ketone, this is ketone, this C double bond O cannot come at the end. If C double bond O comes at the end, we have to read hydrogen also along with that. In that case, this entire group becomes CHO. This is CHO. Are you able to understand here? See here. Yeah, here what is that we have to read is this entire group is to be read basically. This is CHO. This is to be read separately. So, how to read this compound? Aldehydes, functional group formula CHO, general formula RCHO, secondary suffix Al. How do you change it? ANE, E should be changed with Al. Example, propane we had taken earlier. We have attached CHO group for that propane. Carbon, 3 carbon atoms will be there propane. Already 1 carbon atom is available out of this CHO, already 1 C is there, for which we will attach the double bond O and completely read this group as CHO group. And how to read this? Number of carbon atoms in the parent chain. This is the parent chain. 1, 2, 3, prop. Single bond between carbon atoms, ane, propane. Functional group CHO, E should be replaced with Al. Propane, Propane is there, but that E should be replaced with Al. Propanal. When I replace that E with Al, it becomes propanol. It becomes propanol. Clear? So this is how we can represent the aldehydes. Next we will go for ketones. The group ketone group is C double bond O, but as I said, C double bond O, if it comes at either end of the chain, we have to read that as CHO group, aldehyde group, but not ketone group. So when specifically ketone group will come? Look here, ketone group is represented by C double bond O, but there are 2 valencies on both the sides. So this carbon can be attached with R and R dash. R and R dash can be same also. One methyl here we can attach. So what is that we'll read here? See, in this case, ketones, this is the functional group, general formula, secondary suffix ONE, thus E of ane should be replaced with ONE, own, ONE, own. Example, earlier we had taken propane. Okay, now how do you attach to the propane this group? See, propane should have 3 carbon atoms. 1 carbon atom I'll put here and another carbon I'll put here. So meth, eth, prop. So it becomes propane. But double bond O is introduced in between, and the valency of this carbon atom is matched with 1, 2, 3, 4 with hydrogen atoms. So this is how we write the formula for the ketone here. C double bond O, 1 bond is there, attach CH3 group, and 1 bond is there, attach CH3 group. So R C double bond O R, R CO R. So for this ketone group we have attached R as CH3, R dash is also R here, CH3. Okay, good. How to read this one? To read this compound, I know if carbon with double bond is there in between, it is a ketone group, and secondary suffix is to be added as ONE. How to read this? Meth 1, 2, 3 carbon atoms, therefore prop is a root word. Single bond between carbon atoms, ane, propane. Functional group ketone, secondary suffix ONE, E should be replaced with ONE, therefore PROPAN, E is replaced with ONE, propanon. This becomes propanon. Next comes carboxylic acid. Representation, RCOOR, secondary suffix OIC. Carboxylic group, when we attach, it is an acid group, and therefore along with this OIC, generally we name that compound as an acid. How do you attach OIC? For alkanes, the last letter E is replaced with OIC. Example, here let us take 3 carbon atoms, and of course the last carbon atom, when we attach this double bond O and OH, we cannot read either OH separately or C double bond O separately. If this is how we attach this COOH group to the carbon chain, then this entire thing is to be read as carboxylic group. This is a carboxylic group here. Now, question is, how do you read this compound? How many total how many carbon atoms are there? 1, 2, 3. Prop. Single bond between carbon, ane, propane. What is the functional group? Check here. The functional group carbon atom is a part of this chain. You got it? But we can consider this last along with the C, double bond O and one more OH. We have to read this as COOH, and we should term this as carboxylic acid group. So I will read the compound now. 3 carbon atoms, prop. Single bond between carbon, ane, propane. Functional group, COOH. Secondary suffix, OIC. So E of the ane should be replaced with OIC. PROPANE was there, E is replaced with OIC. PROPANOIC, propanoic acid. This becomes propanoic acid. Now comes, if the alkanes contain, if the alkanes are replaced, if the carbon-carbon bond is replaced with double bond, then we have a primary suffix which is coming as ene, and those things becomes alkenes that we have studied. And if there exists a triple bond between carbon and carbon atoms, those are the primary suffix will be -ine. This we have already studied, and those will be alkynes. So between the carbon atoms, if there is a double bond, then those are alkenes. Between the carbon atom, if there is a triple bond, those are alkynes. Example, between 3 carbon atoms, between one set of carbon atoms we have introduced double bond and match the valency. How do you match the valency? 1, 2, 3, 4 hydrogen, 1, 2, 3, 4 hydrogen atom, 1, 2, 3, 4 hydrogen atom. So how do you read this compound? Root word, there are 3 carbon atoms, prop, root word. What is the functional group? Double bond. If there is a double bond, primary suffix ene. After the root word, ene should be added. Prop, ene, propene. This is how we can read this. Suppose triple bond exists. This is the name of the compound. There exists a triple bond here. How do you name this compound? Count the carbon atoms. 1, 2, 3. Root word, prop. If triple bond is there, suffix will be there, but it is a primary suffix. What is the phrase? Wine. After the root word prop, I will add YNE. PROP, YNE, propine. So this is how we can read the hydrocarbons with when we attach the different functional groups. So I think you are able to understand these things. आप लोग सुनिए, 2-3 बार सुनिए, watch this once again, couple of times, listen to the video lecture and try to write yourself. You have to write this. Unless you write in this chart form, you will not be able to understand anything over here. Now what I will do here is, I'll take one methane, first compound alkane, that is methane, and let me try to attach some of these functional groups, and how to read I'll take and how to read we'll see it. First I'll take methane alkane and try to attach these functional groups. Then I'll take ethane and try to attach these functional groups. Propane, already we have taken propane as the base hydrocarbon, and we attached all these functional groups and read the nomenclature, isn't it? So make a note of this one. But when I discuss on the board about the methane, ethane also, and try to attach these halogens, these functional groups, and try to name it, those things also you try to note down. Okay, so for the time being, first you note down. Now I'll take you to the board where I'll explain with the base compound as methane and ethane, and we'll try to attach these functional groups and see whether it is possible or not. Yeah, students, just note one thing here. In the previous slide, this H was R. Now this is correct, RCOOH. This is RCOOH. Once again, earlier I had written as R here, it was wrong. I corrected this RCOOH because COOH is a carboxylic acid group. So correct this part here. Now this is 100% correct, RCOOH. By chance, if you have written RCOOR, that R change it to H. RCOOH is the correct representation of the general formula. Okay, I hope you have noted down correctly. Now we will try to attach the functional groups to methane and see whether it is possible to attach and read the compounds. Already methane, when I say, that it should have only one carbon atom, okay, and there are 4 valencies for that one carbon atom. 4 valencies are to be matched, and different valencies can take different compounds also. Rather than different compounds, different elements I'll say. So heteroatoms, 4 atoms can be attached to the carbon basically, isn't it? So 4 heteroatoms can be there. Let us take first one here, CH4. CH4 is methane. Ink is to be put here. Can you give the different pen? Here, this is this is methane basically. Let me attach halogens here, chlorine, bromine, iodine, etc. See, like this, I will retain 3 hydrogen atoms and 1 hydrogen atom I'll remove and chlorine. So chlorine is going as substituent for hydrogen. So how do you read this compound now? This is root word meth. All these are single bond ane. When there is a halo substituent, then you will have a prefix there. What is the prefix phrase? Chloro, and therefore this is CHLORO, chloromethane. Is it clear? Suppose if I change it to something like here, H, bromine and H. So in this case, root word meth, single bond all in methane. Bromine is a functional group. This is the functional group. Therefore, bromo, BROMO, bromomethane is the compound name. If I attach iodine for this hydrogen, I will add iodine here. This is H here, H here. Any valency you can add this iodine anywhere here. Remove one hydrogen and add that. In this case, this is methane, methane, but iodomethane. This name is iodomethane. So we added halogens and we are able to read chloromethane, bromomethane, iodomethane. Similarly, if I add fluorine, fluoromethane. Clear? Now let us try to attach alcohol groups. Halogens we saw. Let us try to attach. You can pause the video and note down, okay? Let us try to attach alcohol group. one carbon here, and here hydroxyl group OH is attached, and 3 valencies are matched with hydrogen. So carbon valency 1, 2, 3, 4, one hydrogen taken out, replaced with hydroxyl group or alcohol group. How do you read this one? Root word single carbon atom, meth. All single bond, ANE. Functional group, alcohols. Alcohol is the functional group. If alcohol is the functional group, secondary suffix is to be added. What is the secondary suffix? Ane is the primary suffix, and secondary suffix, in order to add OL, it is for hydroxyl group, that is OL is to be replaced with E here. This E is taken with, it is replaced with OL. So this becomes METHANOL, which changed this E with OL. So methanol. Similarly, aldehydes will go for. Next, see here, suppose it is double bond O, H, 1, 2, 3, and only one more H will be there, or this side I'll put so that it is convenient for you. Okay, see here, what is the name of this compound? This molecular, see here, this methanol we can write as a condensed formula as CH3OH, methanol. For this 1, 2, 3, 4 valency matched. What is the functional group over here? I cannot read C double bond O as a ketone here, not possible, because C double bond O is present at the end of the chain, and therefore I have to read this completely. In this case it is CH group, and therefore this is aldehyde group. Valency matched, perfectly matched. So aldehyde group is attached. So how do you read this compound? First one, meth, okay, and this is methane actually, because for the methane we are replacing one hydrogen, 2 hydrogens with this oxygen. 2 hydrogens are replaced basically. So those 2 bonds are taken by this oxygen. So it is methane basically, but this is aldehyde group. This is aldehyde group. Aldehydes, the secondary suffix is Al. So in this methane, this E is to be replaced with Al, and therefore this will be METHANAL, methanol, and condensed formula HCHO. Please remember, this is how we write HCHO, methanol. Can we form a ketone here? देखिए, can we form ketone? C double bond, this is how we represent ketone. C double bond O, one bond here, one bond here. Please remember, if I put H over here and H over here, valence is balanced. Is it a ketone? What is the difference between this compound and this compound? Absolutely there is no difference. And therefore, if I put hydrogen on both the sides, I have to read this as RCHO group only. That is aldehyde group only. That is HCHO, RCHO group. So this is a methyl here for once again. Here it is a methyl which is R and OH here. So CH3CHO, this CH3OH, CH3 is a methyl group. So here HR is nothing but H over here. So HCHO and this, there is no difference between this compound and this compound. So this is not a ketone. In order to introduce ketone, what you must do? Please remember, C double bond O should be in between 2 carbon atoms. What is that? C double bond O should be in between, this should be in between 2 carbon atoms. See here and see here. Then ketone group. Now balance the valencies. 1, 2, 3, 4, 1, 2, 3, 4. Okay, let us balance it. Let me write once again properly. Here I write C double bond O H H. It is not possible. This is not a ketone group, and therefore I'll change this with C here. One more C, one more C. Now definitely this is a ketone group. Balance the valences with rest of the hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Because carbon is tetravalent. H. H. This is a ketone group now. So, dear students, with methane, I could not form ketones. So, what is the name of this compound? I have to have a root word, and in the primary suffix which is ane, E should be replaced with ONE for ketone. Ketone, ONE. Isn't it? So, these are also called carbonyl groups. C double bond O is also called a carbonyl group. Remember. Now, how to name this one? Listen carefully. Parent chain, number of carbon atoms 3. Therefore, root word prop. Single bond between carbon, ane. What is the functional group? This is the functional group. Ketone. If this is a functional group, what should be the secondary suffix? ONE, own. How to change? E should be changed. Where is that E? Here. It should be replaced with ONE. So this will become PROPANONE. The name of this compound is propanone. Condensed formula CH3 C double bond O CH3. This is what it is. RCOR also you can write. Now these two groups are methyl here. R C double bond O R. I can change also. See here, I can put like this also. See, yeah, now. Like this also I can put. So, what is this group here? This group is CH3CH2 R dash, and this is methyl group, this is ethyl group. How do you read this compound? In order to read this compound, 1, 2, 3, 4, this is but. Ane. E should be replaced with this group, ONE, butanone. The name of this compound is butanone. But for this propanone, I have to remove this one because only 3 carbon atoms are permitted in the parent chain. And therefore, I am replacing this with hydrogen here. Okay, so propanone we say. So, with methane, I could form chloromethane, methanol, methanol, but not ketones. I could not form ketones with 1 carbon atom. It is not possible. Therefore, ketones start with propane only, propanone or propanone you can say. Okay. So, ये हो गया. Then carboxylic acid ले लेंगे. We will see carboxylic acid next. You can note down this. What is the group name? What is the group formula for the carboxylic acid? COOH. C double bond O OH. This is carboxylic group. But for methane, only one should be there, isn't it? So, for methane, only 1 carbon should be there. Okay, already it is there. Is valency balanced? 1, 2, 3. No. Can I put hydrogen? Yes, I can put hydrogen. So, how do you read the molecular formula for this? HCOOH. Now, HCOOH is the correct formula here. I have to read this one. For this, I cannot read CHO over here. CHO, I cannot form the compound. Here, COOH, this is the carboxylic acid group, and H here, R refers to H basically here. So, RCOOH means HCOOH. What is the name of this compound? How many carbon atoms? 1. Meth. Root word meth. Single bond everywhere here. See, this double bond we cannot consider for oxygen over here. But if 1 C is there, it is a methane only. So ene. But it is carboxylic acid group. What is the secondary suffix? OIC. How do you change? This E should be changed with OIC, and therefore this becomes METHAN. This E is replaced with OIC, methanoic acid. Is it clear, students? So I took the examples for halogens and alcohols, aldehydes, ketones. Ketones will start with the propane group only, propanone, and then finally methane, methanoic acids, carboxylic acid, methanoic acid. I will take one more example with ethane group and try to see whether I'll be able to attach all these functional groups. Ethane contains only 2 carbon atoms. So when I count the carbon atoms, ensure that in the entire carbon chain there must be only 2 carbon atoms. That is the parent chain I am talking about. Parent chain here I consider as a straight chain. This is called a straight chain. If 2 carbon atoms are there, that I will demonstrate it. So let us take ethane now and try to attach all this. Can you form double bond and triple bond with methane? It is not at all possible because there is single carbon atom. In order to introduce the functional group double bond and triple bond, how many carbon atoms are required? Definitely 2 carbon atoms are required, isn't it? So with methane it is not possible to introduce. अभी फटाफट कर लेंगे. Ethane formula, ethane, it is 2 carbon atoms and balance the valencies. This is C2H6. Let us attach halogens. Halogens Rx. One hydrogen atom I'll remove. This hydrogen. These are all hydrogen atoms here. I hope this is visible to you. Chlorine I'll introduce. So this is root word eth. All single bond in. Chlorine is a functional group, therefore prefix is there. What is the prefix for chloro? Phrase chloro. CHLORO, chloroethane. Next, alcohols will attach. Alcohols is OH. So 2 carbon atoms. For one I'll change with OH. Balance rest all with hydrogen. OH is a functional group here. Okay, it's a single bond here. OH. What is the name of this compound? 2 carbon atoms. Eth. Single bond between carbon atoms in ethane. Functional group alcohol. E should be replaced with OL. ETHANOL. Ethanol. Molecular formula CH3 CH2 OH. Next, third one, aldehydes. Can you give me black pen because it is not writing dark. Okay, aldehydes. See here. C single bond. Let us balance first H. This is ethane. I want to introduce aldehyde. What is the formula? CHO. So in that case CHO is required. 1 double bond O. Anything else? Is it balanced? 1, 2, 3, 4. Yes. This is nothing but here CHO aldehyde group. What is the name of this compound or molecular formula? CH3CHO. CH3CHO. What is the name of this compound? Parent chain 2 carbon atoms eth. Single bond between carbon atoms ene. Functional group aldehyde, therefore E should be replaced with OL. and therefore not oil, ethanol. What is the name of this compound? Ethanol. Next comes ketones. Can you introduce ketones for this? Ethane. No. Why it is so? Minimum required this thing. See, एक यहाँ पे interesting. Something like this. I'll write it. Okay. Now, is it a ketone group here? C double bond. Is it a ketone group here? No. It is aldehyde group here. Because finally, that means what I want to say is, okay, you can put like this also. C double bond O here, like this. Here I'll take one more. H, H and H. Here H. What is this name of this compound? Is there a difference between this and this here? Check this. Write the molecular formula for this. CH3 and this should be read as CHO. CH3 CHO. Already it is CH3 CHO. So it cannot form. We cannot form the ketone group with 2 carbon atoms. In order to form ketone group, you must have 3 carbon atoms. O to you remember. And where you should introduce that double bond O? For the middle carbon atom. See, ketone group cannot come at the end of a carbon chain. Please remember that. So for ethanol, for ethane, we took the halogens, alcohols, aldehydes. Ketones, it is not possible. Carboxylic acids, one more. Let us see, for carboxylic acid, can we form with ethane? Okay. So 1 carbon, 2 carbon. What is carboxylic acid group functional group formula? Double bond O, OH. This is the formula. Balance rest of the valencies 1, 2, 3, 4. H, H, H. This group is COOH. This is R group, methyl group. So this is R COOH, R COOH group. How do you read this compound? This is the parent chain, root word eth, single bond between carbon in, functional group COOH, carboxylic acid, secondary suffix OIC. Where we should replace that OIC? With E. Replace E with OIC. So ETHANOIC, acid, ethanoic acid. If I introduce a double bond here, is it possible? Yes. Between 2 carbon atom, double bond introduce, match the valencies 1, 2, 3, 4. 1, 2, 3, 4. Now this is, what is the name of this compound? Functional group ene. That is, double bond is a functional group attached. How do you read the compound here? 1, 2, eth. Double bond, primary suffix ene. Ethene, ethene. Similarly, so this is ethene. ETH root word, ene is primary suffix. How do you read this compound? Between 2 carbon atoms, if I introduce a triple bond and counting the valencies and balancing the balancing with H, this is how it resulted. Now, what is the name of this compound? 2 carbon atoms, eth. What is the functional group? Triple bond. Primary suffix ene. Anything? That's yeah, primary suffix yne here because triple bond. YNE, ethine. That's all. So ethene and ethine are, for 2 carbon atoms we have introduced a double bond and triple bond respectively. So ethene and ethine. So just I demonstrated to you how to form hydrocarbons using these functional groups and attaching these functional groups to the main hydrocarbon chain. I hope you understand, and let us end the lecture over here. In my next class, I will be taking homologous series, and that is the end of the chapter for the current syllabus. Thank you very much for watching. If you have any doubts, During our live sessions, we'll discuss all those things. And if you have any difficulties in reading the names of the compounds and all those things I'll be taking once again in my live session. So thank you very much for watching.